Welcome to SOLIDWORKS for the Engineering Design Process, Lesson 2, Section 2. In the previous section, you used coincident mates to create an assembly. In this video, you'll learn about the other mating techniques present in SOLIDWORKS and see how they're used when creating assemblies. To illustrate the different types of mates, an assembly composed of a bolt and a nut will be used. Create a new assembly. Open the bolt and nut parts provided with the lesson and place them as shown. You'll begin by experimenting with the most commonly used mate, the coincident mate. Click Mate and select the coincident mate. Select one outer planar surface from each part and notice that the nut rotates to move the two selected faces to the same plane. This is essentially the functionality of the coincident mate. It causes two surfaces to become coplanar, meaning they will be in the same plane. Switch to the front view to observe this more clearly. For now, undo this mate so you can experiment with other mating techniques. Next, you'll experiment with the parallel mate and see how it differs from the coincident mate. Click Parallel Mate and select the two surfaces as shown. The nut rotates to make the selected surfaces parallel. It's important to understand the difference between coincident and parallel mates. The parallel mate only rotates the nut to make the two surfaces parallel, while the coincident mate both rotates and moves the nut so that the two surfaces are not only parallel, but also in the same plane. The next mate you'll learn about is the perpendicular mate. As its name implies, it rotates the nut so that the angle between the two entities is 90 degrees. Undo this mate so you can move on to the next type of mate, the tangent mate. The tangent mate is used if you want to mate a rounded surface with a flat one. The tangent mate is best demonstrated by first clicking Tangent Mate and then selecting this round surface on the bolt and this flat surface on the nut. Observe that the flat surface is now tangential to the round surface. Undo this mate so you can experiment with the concentric mate. The concentric mate allows two round entities to share the same center axis. Click Concentric Mate and select the two surfaces as shown. Observe that the nut and the bolt appear to be tightened together. This is because they now share the same center axis. If you wish to assemble these parts without mating it any further, click the Lock Mate. Select the two parts and apply the mate. This assembly has now become fully defined. For now, remove the lock mate so you can experiment with other mates. This is done by clicking the green check mark to exit the Mate Property Manager, expanding the mates in the Feature Manager design tree, right-clicking the lock mate, and clicking Delete. Click Yes to confirm the delete. The distance mate will move the two selected entities a specified distance apart. Select the two surfaces as shown and set the distance to 25 millimeters. Observe that the two selected surfaces are now 25 millimeters apart. The angle mate creates a specified angle between two selected entities. Click the angle mate and select the two surfaces as shown. For example, enter an angle of 20 degrees and notice the nut rotates so the angle between the two surfaces is 20 degrees. Another feature of SOLIDWORKS that is worth discussing is the automatic mating feature. Delete all the previous mates so you can see how this works. For example, if you wanted to create a coincident mate between these two surfaces, you can simply click the two surfaces while the Mate Property Manager is open, and SOLIDWORKS will automatically select the most appropriate mate. In this instance, SOLIDWORKS has selected the coincident mate. If you wanted a parallel mate, for example, select it and SOLIDWORKS will undo the coincident mate and apply the parallel mate. The automatic mating feature also works for concentric mates. If you select two circular edges, SOLIDWORKS will automatically apply the concentric mate. In this video, you learned about the mating techniques for creating assemblies in greater detail. You also learned about the automatic mating feature present in SOLIDWORKS.